Hey everybody, before we start the new video, I just wanted to show you the completed binary clock from the last video. And that was the January 1991 Popular Electronics project. So when I left that video, I was just showing you the circuit board and it working and how it works, etc. So in any event, I promised that I would put it in a case, and I did. So this is the case. So yeah, I think it looks okay. I'm not too proud of the labeling, but well, it'll have to do for now. So if we read the clock right now, we're reading 11 and 19. So it's 11:19 and about 43 seconds. So that should go over soon to 11:20. Yeah, so anyway, hope you like it, and let's get on with the new video. Hey everybody, thanks for watching this video. I really appreciate it. If you haven't already subscribed, please consider doing so. It would help my channel out very greatly. So we're going to build another Popular Electronics project. Yes, another one. I think I'm going to make a series out of these. There's so many good things to build from Popular Electronics, radio electronics, etc., etc. In any event, today we're going to build a 30-watt audio amplifier. High fidelity, high performance, and low cost. Hey, that's what I'm all about. All right, let's just bring you into the actual article itself. It's not very much, to be honest with you. It's a 3-page project in Popular Electronics. So there's what it will look like at the end, by the way. So it's very simple, not very many parts. And the reason there's not very many parts is because we're using an output chip, a TDA chip, a TDA 2004. So obviously that's where most of the important stuff is, and we just have to add a whole bunch of external components to make an amplifier. I'm going to build 2 of these, so we have stereo. Each one of these is mono. Now, I've ordered the chips from eBay, and I got them from a Canadian source. I'm pretty sure they're legitimate. So if you're watching this video, that means I've got the parts and they're genuine. In any event, it's, yeah, there's really not much to say about it. I've got the PC boards ready. I've cleaned them up, and I've scratched them up a little bit for the toner transfer. We'll use the toner transfer method again and see how that goes. I've got most of the parts. I am waiting for some potentiometers. There should be in a couple days. And that TDA chip, I don't know when that's going to come in. In any event, I'll build this once I get all the parts. There is the PC board. Pretty simple. Nothing fancy about that. And it looks like we're going to have an external power supply. So what I think I'm going to do is I'll probably put both channels in an aluminum box. And I'll put the power supply in the middle. So yeah, it'll be one unit. I'll have 2 inputs and 2 outputs for the speaker, and I'll have another audio amp. Just what I need, right? I mean, I've got a million audio amps right now, but we're doing this for the fun of it, right? So that's why we're at it and to it and at it. Here's the components, not much. Transistor, the chip, some capacitors, and some resistors, etc., etc. So that's what they're thinking, or that's what it should look like once we're finished. But we'll have my version, and we'll see how that goes. In any event, so the next thing up for bids is the PC board. So I will get the toner transfer machine working, heat it up, get it warmed up, and we'll make some PC boards. So that's where we'll go next. So hang on. Okay, let's move on to the toner transfer method. Just before we start, I wanted to explain that you do need a different kind of a paper. And the one I use that always works is the Hammermill Premium Laser Gloss paper. And I've printed out the actual circuit board design from the Popular Electronics magazine, and I've got it on that paper. I've cut them out. There's 2 channels, and I'm going to transfer it on to those PC boards using a laminator, which I'll show you in a second. Now, there's plenty of videos out there explaining the toner transfer method, so I don't want to get into details of it, but suffice it to say, you do need this paper, and you do need a LaserJet type printer. I'm using an HP 2000D printer. It's an older one, but I bought it specifically for this purpose. And of course you need this paper. So let me warm up the laminator and I'll get right back to you and we'll show you the steps. Okay, here's my laminator. I think I bought this at a flea market, or maybe a Hamfest, I'm not too sure anymore. In any event, it seems to do the job. It's an EL12, Ibeco. I'm sure you could find some other ones that work just as well. I've got some different temperature settings. Right now I'm at the highest, which I think is probably most appropriate. And it's been warming up for about 10 minutes at least anyway, so it should be ready to go. And in fact, I've already put the board through a couple times just to get the actual paper adhered to the actual PC board. So you can see that I've got the PC board and of course the transfer. And well, all you have to do is just run it through. Now wear gloves because this does get hot as it comes out. So I'm just pushing it in, as you can see. And I'm going to do this, I don't know how long, until it just looks good coming out of the other end. So you can see some of the traces look to be on the PC board, but I'm going to run it through, oh, I don't know, let's say about 10 times or so, just at different angles and different areas of the laminator, and we'll see what happens. Okay, instead of me keeping you tied up on this, let me do both boards, and then I'll show you the next step. All right, hang on. Okay, let's move on to the next step. So the next step is to get the paper off of the PC board. And the beauty of this hammer mill paper is it'll easily come off and it'll leave the trace behind. So let's put one in. Just regular cold water. Nothing fancy. Just let it sit there. Let the water get into the paper. I'll flip it over. I'm doing this with one hand, so it's not that easy. I probably should invest in some proper camera equipment. Or so at least a tripod at the very most. But anyway, we'll make do with this. So it's coming along. And I can actually start to peel it off a little bit. Now I don't want to go too fast. But it is coming off. And I've tried other glossy paper other than the hammer mill. And the problem with the other glossy papers is that the paper won't come off. It just doesn't peel off. That's why I really like this hammer mill paper. So there you go. Let's get that in my hands here. Okay, let's just go for broke. There it is. So just looking at it through the camera, it doesn't look too bad. Yeah, it doesn't look too bad. So what I'll do, if the lines aren't as perfect, I'll just use a Sharpie just to color things in. Like I can see some spots there that never got transferred. And that's because of the actual printout that I got from Popular Electronics. You can see those holes. And those holes shouldn't be there. Of course, you know, the quality of the traces from Popular Electronics, it's not going to be that great. Now, if you had the original copy print version of the magazine, it would probably be a lot better. But I think we can make do with this. So let me get the other one done. And then at that point, what's next is the actual etching. So I'll get that set up and we'll come right back to the video. Okay, we're at the etching station, if I can call it that. And I've got the fume hood, of course, working. And I've warmed up the etchant. And in fact, I've already got one board in there. Let's see how it's doing. If I can get it in or get it out. Oh boy. This ain't really working out so good. Anyway, the board is in there and I'll let it sit there. I've got the other board here. I haven't started it yet. Only because I think I could fit 2 boards in there, but the problem is it's might scratch, you know, the traces or whatever. So I just want to be safe. So anyway, let me get the boards done and then I'll clean them off and I'll show you the results. All right, don't go anywhere. I'll be back. Okay, so the boards are etched. So in front of you are both the boards. Now, the one on the left, of course, it's cleaned. I've taken off the black plastic, if you want to call it that, from the actual printer onto the transfer. And the one on the right is still not cleaned. I just wanted to show you the difference between the two. And the way you clean the boards is with lacquer thinner. You can get this at any hardware store, I'm certain of it. So there they are. Didn't turn out too bad. Some, as you can see, the traces look a little bit airy or Swiss cheese-like, but that's what you're going to get from the quality that you're given. So you got to remember, these popular electronic magazines were scanned, put on the internet, and then I printed them out. So you're going to lose some of the resolution, of course. And like I said earlier, if you had the original magazine, I'm sure the copy that you would get would probably be a lot better. And just as a note, the one on the right, the reason it's not black is because when I did the toner transfer, some of the paper still stays on where the traces are, very, very light. And that's why you're seeing it. And it would, if it was wet, it would be actually black. But anyway, in any event, I'm going to take that off with the lacquer thinner, and it'll look just like the one on the left. So let me get that done, and then I'll show you the drill process. I'll drill the holes. And, oh, before I forget, it's very important because the quality of your transfer isn't the greatest. You need to actually look at all of the traces and use a loop if you have one. And you gotta look for cracks because I guarantee you there may be 1 or 2, if not more. And if you do find them, you gotta fix them now. And you don't want to actually start building your circuit and putting the components on and finding out that the circuit doesn't work. So definitely check your tracks and fix them if you need to. All right, so let's move on to the drilling process, and I'll get that set up and I'll show you. Okay, we're back at the bench, and I've got the drill press, and I've got the holes drilled on the PC boards. So what I do is I just put the PC boards, tape them onto a piece of wood, a piece of scrap wood, and then I drill them out. And just a warning, safety first. Wear some glasses, wear a breathing mask of some sort, and some ear protection. So the setup I've got is I've got this Dremel, and it doesn't quite fit into this press. It might look like it does, but it really doesn't. But I made it to fit, and it seems to work. So I know a lot of this stuff that I have and I've been doing requires a lot of kind of infrastructure. And if you are building some projects, and if you don't have all of this stuff, just start collecting it and start building your lab, and you will get all this stuff eventually. So anyway, that's the drilling process. So the next step is to actually put the components in, and I'll do that, and then I'll get right back to you. Hey everybody, I'm back. Okay, so the board is populated, as you can see. The other one is too. I've got it over on the other bench. I was testing it just to make sure it works, and it does, along with this one. This does work. Now, you're probably wondering, well, why are all the components on the board that looks upside down? Well, it's not my fault. The design that we got actually is kind of upside down, and when they made this magazine back in 1990, anybody else that did the toner transfer method, which was a pretty popular way of doing things back then, would end up having to do the same thing I did. I don't know if they did that intentionally. I'm not too sure. I know in some of these projects, you can actually order the board. So maybe they did this on purpose. I'm not too sure. But while we're at it, there is just a note, there is a jumper between these 2 points here, and there was a bit of a trace missing here. Again, maybe they did that on purpose. I'm not too sure. In any event, yeah, so the other way, well, you could have done it maybe with the photo etching type method. You could have printed this out instead of a piece of paper that you're looking at right now. It could have been a transparency, and with that transparency, I could have just flipped it around and then did the photo etching and etc., and it would have been the right way. However, I didn't want to go through that. I already made the boards, and I said, let's just go with it. There is just one difference here. If you are keeping track, the transistor I'm using is kind of the other way around. It's a 2N3904, and as opposed to the original request of a BC587, the pins are just different. So that's the only difference. Yeah, so again, the board is a little bit airy, or yeah, a little bit airy and holy. Again, the trace from the magazine wasn't that great, so obviously when I transferred it over, it wasn't that great. Now I'm thinking next time when I do a board, I'm wondering if I could find some sort of a program, now that we're in 2025, that would maybe take the traces themselves, somehow outline them, and then make them darker, like a dark black or something like that. And then I could print that out and then, of course, transfer it over to the board. So just something I'm thinking about. I don't know if I can do that. I'm sure there's got to be some program out there that can do that. But for now, this is what we have. So yeah, I think right now we're at the point where we can probably put it in a box and present it. But before we do that, actually, is test it. So let me set up this amplifier over at the test bench. We'll put a signal through it, and you can actually hear it on the speaker. I can have it on long, only because I don't have a heat sink yet on here. Yes, I do have some heat sinks over here, but we'll just put a signal in just to see if it works. Okay, all right, let's get at that. Okay, so we're at the bench now. Let's test this board out. Just as a note, I've got volume, treble and bass, or bass and treble, I'm not too sure. I've got a speaker, and I've got a power supply up here, and I've got a function generator with a sine wave. And yeah, that's probably just about it. All right, so let's turn the power on and see if it works. And yes, it does. Okay, that's enough. I don't have a heat sink, like I said, so it's gonna get a little warm. All right, so what we're gonna do now is we'll put these boards, like I said, into a box. I have to build a power supply, and yeah, so that'll be the next one. The next part of this video will be the final part. All right, hang on. Okay, I am done. The amplifier is in its case, and it works wonderfully. My God, I had this thing on for over an hour, and it was up pretty loud too, quite frankly. And the heat sinks on the back barely got warm, so I'm happy about that. There's a right channel, left channel heat sink, and then there's a bridge rectifier heat sink there. And yeah, so just going over the front, you probably already know this. We've got the volume for each channel. We've got volume, treble, and bass. Worked fantastic. Really happy with it. I did have these knobs from a guitar amp repair, so they are brand new. So I did pay for them. Anyway, I've got the line in, of course, and then that goes to your speaker. And the same with the left channel. I have two power lights. Yeah, you only need one, I know, but I put two. And it's actually kind of good that I did, because it actually fluctuates with the music. Like when you really have it up loud, I just tied those LEDs onto that 19-volt supply, which I'll talk about in a minute. Yeah, it works great. Really, really happy. Now, I don't need another amplifier. I've probably got about 20 amplifiers in this basement somewhere. But it was fun, and I hope other people are interested in building an amplifier too. It's a great way of learning and honing your skills in building electronics. And yeah, I've always liked the popular electronics, radio electronics, or no, I think it was electronics now, I think. Or radio now, or I can't remember. Anyway, tons of good stuff in there. And this is the inside of it here. I've got a switch. Actually, I had that switch from an old something or another, so I didn't have to pay for that. I also had the transformer. I think I got that from an organ. And by the way, in the spring/summer, I will be getting a lot of organs from people that give them away for free. So tons of good stuff in them. Anyway, it probably puts out about 15 volts AC. I've got it fed into a bridge rectifier, you can see on the back. And of course, the smoothing cap, I probably end up with about 19 volts DC, which is totally fine. The TDA 2004 can operate between 8 and 24. So the schematic asks for 12, but you know what? 19 sounds even better to me. So what else do I have here? I had to, because the TDA chips did not touch the actual, the box, I had to put some spacers in there. I just had some spare aluminum I threw in there. And like I mentioned, there's 2 heat sinks for the audio channels. And yeah, nothing special. I just, again, I had free wire because I have a whole bunch of wire from computers and all that kind of stuff. So it did it on a budget. Yeah, and that's about it. So thank you for watching. There are going to be more videos. I'm going to continue this popular electronics theme. So I'm going to pick out a project, and I'm going to try to do it every week. Hopefully I can keep up. I have something in mind for the next project next week. But I hope you enjoyed this video, and thanks for watching. And if you haven't already, please subscribe. Bye for now.